Okay, so this video we're going to go over the last example, and we're going to talk about interpreting a function of this sort. So in this case, the function represents the height of a ball t seconds after it's thrown from the top of a tall building. So it's important, I think, as soon as you're dealing with a new function to write out what the input is and what the output is. So the input here is t. And what's t? T is the time in seconds since the ball was thrown. And what's the output? Well, the output is the height of the ball at that time. So let's start with a question that we should be able to answer, which is, how high is the building? So how am I going to figure out how high the building is? Well, I have to think back to the story that went with the question and figure out, okay, if the ball is thrown at time t equals 0, it's thrown from the top of the building. So the height of the ball at time 0 is how high the building is. So h of 0 is how high the building is. But I can actually use the formula that I was given to figure out what h of 0 is. Namely, h of 0 is minus 16 times 0 squared plus 48 times 0 plus 160, which is just 160. It's at about this point that I realized I want to put units here, and so then I realized I didn't put units here, and I realized that's because I didn't actually give you units in the original question. And so I'm going to add to the question height in feet, just so we know what the units are, okay, which means that this height is in feet, okay, which means that this 160 is feet. Okay, this is an output of this function, and the output of the function is in feet, so this is 160 feet high. Next question. When does the ball hit the ground? And so here again, I have to combine my skill of interpreting what the function means to figure out what hitting the ground means, and then use algebra to actually answer this question. Well, h of t, that's the height of the ball above the ground. So when the ball hits the ground, the height of the ball above the ground will be 0 feet. So what this question is actually asking is for me to solve h of t is equal to 0. Or in other words, for me to solve minus 16t squared plus 48t plus 160 equals 0. Okay, and this is equals 0 because the ground is 0 feet above the ground. Okay, so I want to solve this. One thing I can notice that will make my life a lot easier is that all of these coefficients are divisible by minus 16. So I'm going to divide everything by minus 16, including the 0 over here, which will give me t squared minus 3t minus 10 equals 0. Okay. This, again, I just divided. 0 divided by minus 16 is still 0. Now I can factor this. So this will be t minus 5 times t plus 3 equals 0. And so this actually gives me two answers. T equals 5 and t equals minus 3. But again, here we need to use our mind to think about what this is actually telling us. And so you might think, oh, there's two solutions. It means the ball bounces and hits the ground again, which would make sense, except one of these solutions doesn't even make sense at all. Namely, this t equals minus 3 is talking about the ball hitting the ground 3 seconds before it's thrown. So this actually does not even make sense. So that's not the one that we want. And so by process of elimination, t equals 5 is the one we want. So in other words, 5 seconds after it's thrown, the ball hits the ground. Next question. How high does the ball go? And so if you picture what the graph of h of t looks like, it's maybe worth sketching it. Here's the 160 That's the y-intercept. So you can think of this as sort of like the building. And then the ball is thrown, and it's thrown upward, so it initially travels upward. And then it comes down, and it comes and hits the ground. And we've just said the spot where it hits the ground, that is at 5 seconds. And so this question is really asking us, what is the height of the ball at this point? Okay. And so to find that, we have to think about what this point that I'm looking for is in terms of the parabola that we're looking at. Namely, this point here, it's actually the vertex. So our question here is really asking, what is the y-coordinate of the vertex of the function that's given by, and I'll repeat the function since it's no longer on the screen, minus 16t squared plus 48t plus 160. Okay, so once I realize that this is really asking me for the vertex, I can use my vertex formula, which is this negative b over 2a business. Okay. Namely, that the vertex happens at, and I said x equals before, but our variable is now t, so the vertex happens at t equals negative b over 2a, which is negative 48, divided by 2 times negative 16, which is negative 32. And if I divide a minus 16 from both of these, I get 3/2. Which is to say, the ball gets to its maximum height 1.5 seconds into its flight. It's very easy to feel like we've answered the question and then move on, but we haven't actually answered the question, because what we've given is a time, and what the question is asking for is a height. Namely, we've given an input, whereas the question itself is actually asking about an output. So to complete the answer, we actually have to find h of 1.5, or h of 3/2. Okay. I'll go ahead and do that real quick. So this is minus 16 times 9/4 plus 48 times 3/2 plus 160. And so after doing some fraction math, it's maybe a little messier than I would usually have you do, but not ultimately too terrible, we get that h of 3/2, or h of 1.5, whichever you like, is 196. And this is an output, so it's in feet. And that is the answer we really want. So to fill in our picture, this happens 1.5 seconds into the flight that we get to this vertex. And the height there is 196 feet. So in other words, the ball rises an additional 36 feet above its original height at the top of the building before it starts to fall. So our last question here is, how long does it take the ball to return to its starting height? Okay. Its starting height was 160 from this picture, and so I'm really asking, if we think about it in terms of this picture, how long does it take for the ball to get back here? Okay, so namely, I'm asking for that time. Now, probably you could actually make an educated guess just from this picture as to what this time is. But we don't need to guess. We can actually do this by setting this equation equal to the number we want. Namely, I want to answer the question, when is the ball 160 feet in the air, which is its original height? I should just set this equal to 160. I'll subtract this 160 over here, so it'll give me minus 16t squared plus 48t equals 0. I'll factor a minus 16t out of this, and I will find actually 2 times when the ball is at its starting height. t equals 0 coming from that t, and t equals 3 coming from that t minus 3. Now, this t equals 0 is a little bit of a red herring because this is telling you after 0 seconds, the ball returns to where it was at time 0 seconds. So this is a MacGuffin. We can ignore this. And so then we're left only with t equals 3. So that's telling me that it takes 3 seconds to return there. Now, I mentioned that you probably could have guessed that. How could you have guessed it? Well, if you look at my picture here, I'm really looking at just this piece, and I would probably guess, correctly, that the vertex would be exactly in the middle of this piece. Okay. And so halfway across it was 1.5, and so in fact all the way across it would be 3. And so you would correctly interpret from the picture that in fact it takes 3 seconds for the ball to get back to where it started height-wise. All right, that's all for this section. We'll be back shortly with the next section where we'll start talking about logarithms. But that's it for now. I'll see you next time.